Okay, example 2, let theta be the acute angle in standard form or standard position, not standard form, sorry. Okay, let theta be the acute angle in standard position whose terminal side contains the point five, 3. Find the 6 trigonometric functions of theta. Okay, so theta is a angle in standard form. Okay, that means its vertex is on the origin, the initial side is on the x-axis. And it says its terminal side contains the point 5, 3. Okay, that means on a graph, the horizontal distance of this triangle is 5 and the vertical distance is 3. Okay, so I'm working with a triangle then. That looks like this. Okay, so I need to find the length. I need to find my 6 trig functions, right? So I've got to find the length of the hypotenuse as well. So I have 9 plus 25. It's 34. Okay, there aren't any perfect squares that go into 34, so the hypotenuse of this triangle is 34. Okay, you can still label these sides if you need to. Theta is this angle right here. Okay, so this is our theta. So this side would be the opposite, this would be the adjacent, and this would be the hypotenuse. Okay, so if I'm writing my trig functions, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Okay, and then cosecant is just the inverse of sine. Okay, secant is the inverse of cosine, and cotangent is the inverse of tangent. Okay, let's look at one that's not in the first quadrant. Okay, so same directions basically. Let theta be any angle in standard position whose terminal side contains the point -5, +3. Okay, and then again find the 6 trig functions of theta. Okay, so same thing, right? This angle is just over here now at -5, 3, right? So if this is in, right here's my angle. Okay, so it goes through that point, -5, positive 3. Okay, but what I'm going to do here is I'm going to make a right triangle out of this. Okay, so that's my angle. But I'm going to create a right triangle out of this, like this. This is theta. That means that the horizontal distance is -5 and the vertical distance is positive 3. Okay, so once again, I need to find the length of the hypotenuse. It's going to be the same as the other one because I'm basically using the same numbers, just the 5 is negative, which doesn't matter because I'm squaring it. Okay, so the length of the hypotenuse is the square root of 34. Okay, so sine of theta, again, here's theta, this is the opposite, this is the adjacent, and this is the hypotenuse. Okay, so sine of theta is opposite over hypotenuse. So that's actually the same as the last one, it didn't change. Cosine is -5 over square root of 34. Okay, so that negative matters. So it is the same for the most part, except for the sign. Okay, so when an angle is in a different quadrant, it's going to change the sign of the trig function. And the tangent is the opposite over adjacent. Okay, so you would write this, I guess, 3 over -5, right? But when we have a negative in a fraction, it doesn't matter if it's on the top, on the bottom, in the front. Okay, so I'm going to write this as -3 over 5. Okay, cosecant is the inverse of sine. Secant is the inverse of cosine, and cotangent is the inverse of tangent. Okay, again, don't get caught up on the fact that the 5 is a negative here. It's just a fraction. You're dividing a negative by a positive or a positive by a negative, so it makes the entire fraction negative. Okay, so the sign of the function in that quadrant is negative, the sign of cosine and the sign of negative, and the sign of cosine and the sign of tangent, secant and cotangent are all negative. Okay, and this angle is in the second quadrant, and we're going to talk more about that in the next example.